welcome back to Unacademy. Unacademy is the India's largest online learning platform. Now it is training for GATE and engineering service students also. So about myself, I G Venkata. I have total 16 plus years of teaching experience. So far, I mentored 60,000 plus students for their GATE examinations. At present, I am pursuing PhD from JNTU Kakinada in VLSI domain. First, we check how to get the Unacademy Learning app. Just go to Play Store. In that, type Unacademy Learning app, and at this end, you get the install button. Just click on that install button. By clicking on that install button, it will install Unacademy Learning app in your device. Once you open that, you get what are the different courses offered in that, and with respect to that, top educators who are going to handling those courses. Here we check some of the top educators who are going to handling the GATE and engineering service classes here. Here a few more. And recently Unacademy started new batches for GATE 2022 students and GATE 2023 students in few disciplines. First one is they started GATE 2023, that is for YV batch. This is especially for electrical students. This batch was started from 18th of January. Next, Spark batch. This is for GATE 2022. This is for ECE students. It was started out from 18th of January. During the subscription of this, don't forget to use my code VROW10. Okay, use my code VROW10 during the subscription of this. Next, this is the YV batch for ECE. So for GATE 2023, it was also started from 18th of January. Now use my code VROW10 during subscription to get 10% discount. Next, this is again Spark batch for GATE 2022. Now this time this is for electrical students. It is also it was started from 18th of January. Here also you can use my code VROW10 to get the subscription with 10% discount. Okay. Next, for civil engineering, there is a Evolve batch for GATE 2022. This is for civil engineering department. Now it is going to start from today. Okay. During subscription, use my code VROW10 to get 10% discount. And next, again for civil engineering department, this is for GATE 2023. Okay. During subscription of this, just use my code VROW10 to get 10% discount. This is going to start from 25th January today. Okay, next for chemical engineering, this is the Evolve batch for GATE 2022. Okay, it is also started from 25th January today itself. So during subscription, use my code VROW10 to get 10% discount. Next, mechanical engineering. This is a GATE 2022 Evolve batch. Sorry. So it is also going to start from today, 25th January. So during subscription, use my code VROW10 to get 10% discount. VROW10. This is my code. Use it to get 10% discount in your course. Next, mechanical branch. This is a Ascend batch. And now this is for GATE 2023. It is going to start from 25th of January. Use my code VROW10 during subscription to get 10% discount. This is my code VROW10. Okay. Now we go and check Just a moment. What are the different branches or specializations available in an academy for GATE and engineering service examinations? Here, mechanical engineering, electrical engineering, electronics and communication engineering, computer science and IT department, civil engineering, instrumentation engineering, production and industrial, next chemical engineering. Okay, these are the different engineering streams available here. Next, here two types of subscriptions are there: plus and iconic. Plus subscription and iconic subscription. Plus subscription is the basic plan, iconic subscription is the next level. Okay, here personal coaching is going to be, personal care is going to taken care. Now in both the cases you get the classes from India's best educators and interactive live classes, structured courses and PDFs, live tests and quizzes you get. Here also you get the same thing, but after completion of your examination, your answer sheet is going to be verified, okay, analyzed, and from that they will identify where you are strong and where you are weak, where you need to improvement. They will prepare a study planner based on that, okay, and they will provide that study planner to you. By following that study planner, you will definitely get success in your career. Okay, that is the important thing in iconic. Okay, so personalized attention is more in iconic. Now we check for plus subscription how much they are charging, and for iconic how much they are charging. Now for plus, for 1 month subscription it is 5,500, and 3 months 13,700, like this. 6 months, 12 months, this is 1 year subscription. Similarly 1.5 month, 1.5 year, and 2 years. So in this subscription of 12 months, 1 year subscription, you get 10% discount. You get 10% discount by using my code VRAO10 during subscription. Okay, the cost of this one is, after 10% discount, it is 27,225. Okay, sorry. Similarly, whatever the subscription you want, use my code VRAO10 to get 10% discount. Next, I am going to iconic subscription here. Here in iconic, only two options is there. One is a 12-month subscription, second one is 24-month subscription. That means a 1 year and 2 year subscription. For 1 year they are charging 50,250, and for 2 years it is 74,000. okay, after getting discount it became 45,225. so during subscription you have to use my code VRAO10. Don't forget that. Okay, don't waste time, hurry. Okay, join as early as possible and starts your preparation, because whatever thing is happened at outside, your learning process cannot be stopped. That is the main intention here. Okay, now already last class we complete the few of the problems in drift current density, and due to time factor we left two problems, and I added the, we are going to discussing the problems here also. Now these are the current equation, drift current density equations for intrinsic, n-type and p-type, and these are the equations for conductivity of intrinsic, n-type and p-type. Previous class we discussed in detail about this. Okay, I'm not going to wasting time on this. Now directly I'm going to problem. See this problem. A voltage of 10 volts is applied across an n-type silicon semiconducting bar. 10 volts they applied, fine. Having a rectangular cross section and a length of 1 centimeter as shown in figure. Rectangular cross section and length is 1 centimeter. 1 centimeter, fine. The donor doping concentration Nd and the mobility of electrons mu n or donor impurity Nd they given 10 power 16 per centimeter cube and mobility they given mu n 1000 centimeter square per volt to second, centimeter square per volt to second respectively. The average time in microseconds taken by electrons to move from one end of the bar to the other end, from this end to from this end, one end to another end, to travel an electron, how much time it is going to take, that is you need to calculate. Okay, and first of all you are applying some external voltage to a semiconductor. So once you are applying external voltage, in this sense externally you are applying an electric field like this. Once you are providing external electric field, now it became drift current and drift movement of the carriers. Now the drift velocity, we know that the amount of length or distance of the electron traveled by the amount of time it taken. We need to measure time, therefore from this time is length by drift velocity. Now how to get the drift velocity? We know drift velocity is equals to mobility of electrons into applied electric field, and applied electric field is applied potential difference by length. Now it is 10 by 1 volt per centimeter, so this is a 10 volt per centimeter. Just take that E value and substitute here, you get the Vd. Therefore Vd equals to mu n, it is 1000 into 10, so this is a 10 power 4. Okay, this is the drift velocity, centimeter per second. Take that value and substitute in this. Therefore T is equals to the amount of time taken by the electron to travel a distance of 1 centimeter, that means from one end to another end, is length L, they given it as 1 centimeter, by drift velocity Vd is 10 power 4 centimeter per second. Now it is 10 power minus 4 seconds into 100 by 100. So therefore T is equals to 100. T equals to 100 microseconds, because they asking the answer in terms of microseconds. So this is the data we got. T is equals to 10 power minus 4. Now I am multiplying and dividing with 100, simple. Now I am keeping this 100 as usual, so it is 100 into 10 power minus 4 by 100, it is 10 power minus 6 seconds. So that is 100 microseconds. So this is the amount of time required to travel the electron from one end of the semiconductor bar to other end. One end to other end. Yeah. Next problem. See, a Fermi level position in a silicon sample at 300 Kelvin is 0.29 electron volts below the EC. Below the EC, that means EC minus EF Fermi level is 0.29 electron volts. Determine the carrier concentrations and conductivity of the specimen. Sir, first of all, at 300 Kelvin they are saying, and it is a silicon sample, For silicon sample at 300 Kelvin, we know that energy gap is 1.1 electron volt. Half of the energy gap, that is intrinsic Fermi energy level, is 0.55. EFI is 0.55 electron volts. So this is less than the given EC minus EF is 0.29. So this is the plot. EC and EV at center, this is EFI. Now here they given this is your EF, Fermi energy level. Okay, so this is 0.55 electron volts, 0.55 electron volts. Similarly, this is also 0.55 electron volts, 0.55 electron volts. This is also. Now they given this distance is 0.29 electron volts. Okay, so from this it is clear that it is n-type semiconductor. Now they given EC minus EFN 0.29 electron volts. Now you need to measure the carrier concentration and conductivity of the specimen. So conductivity is amount of doping Nd into Q into mu n, or in n-type amount of doping or majority carrier concentration n, both are same, n into Q into mu n. They given already mu n, we know the Q, now we need to measure the n value. So from this we can relate these two. Now that relation is, that equation is EC minus, see this, to get EC minus EFN we have one problem. They did not given any NC value. This is our regular equation, sir. EC minus EFN is KT into ln of NC by ND. This is the problem formula, but here they did not give an NC value. That's why I am not going to use this equation, because they did not provide sufficient data for this. Now see this, instead of going to this I am going to using these two, because here I need Ni value, they given Ni value, we need to measure this. So now the equation what I am going to using is EFN minus EFI is equals to KT into ln of ND by Ni, ND by Ni. Now this is 0.29, now this is 0.55. Now the value of this one is 0.55 minus 0.29, 0.55 minus 0.29, now it is 0.26. okay, 0.26. so 0.55 minus 0.29, so that is 0.26 electron volts. So now it is 0.26 electron volts. Now KT is 0.026 electron volts into ln of ND, we need to measure that, by Ni, 1.5 into 10 power 10. Now okay, now this one cancel in this 10 times. Okay, now I'm taking natural log on both sides, so it is 10 is equals to ln of ND by 1.5 into 10 power 10. okay, now it is from this e power 10 is equals to ND by 1.5 into 10 power 10. Therefore ND is 1.5 into 10 power 10 into e power 10. Now I am going to that, getting that value, e power 10 that is e power 10 is, this value is 22.026 into 10 power 3. By substituting that value here, you get the ND value. Take this ND value, substitute here, then you get the conductivity. Already this method of problems already we solved in problems part 1. Okay, so this is the procedure you need to follow here. Now I am moving to next problem. See here, an intrinsic silicon wafer is, this is intrinsic silicon, sir. So here an intrinsic silicon wafer is doped with 10 power 16 arsenic atoms. Doped with 10 power 16 arsenic atoms. It means it is doped with Nd. So Nd is 10 power 16 per centimeter cube, and this is N type. Now, if the small amplitude of low frequency alternating voltage of V input is applied across the block, so small alternating voltage, small amplitude of alternating voltage, V input they are applying to this. Okay, now applying to that across the block of this doped silicon, a current I input, small I input is flows through. Assume the block is a cube. This block is a cube. This block is a cube. This block is a cube. Cube of side of the cube, each side is 5 micrometer, and all the dopants are ionized. Find dou V in by dou I in. Okay, so we need to measure dou V in by dou I in. We know one thing, voltage by current is nothing but a resistance. So you need to measure the resistance. That's it. How much it is. And we know the equation for resistance. R is equals to rho L by A. Okay, here it is a bar. So this is N type. Now it is a rho N. Now it is L by sigma N into A. So it is a cube of each side 5 micrometer. Now this is side. If you take it is L, now area equals to L square. L into L, it is L square area. So it is a L by sigma N into L square. So at first case, this L and this one gets cancelled. Now I am writing sigma N value. Sigma N is Nd into Q into mu N. Just take the values and substitute here. Now R equals to 1 by sigma N. So sigma N is Nd into Q into mu N into L. Just take the values of that and substitute here. Now it is 1 by Nd is 10 power 16 into Q is 1.6 into 10 power minus 19 into mu N is electron mobility 1000 into L is 5 micrometer. Everything given in centimeters. Now this is in 5 into 10 power minus 6, 10 power 2. So it is 10 power minus 4. So 5 into 10 power minus 4. So I am converting that L is 10 power 5 into 10 power minus 4 centimeters. 5 into 10 power minus 4 centimeters. Yeah. Now simplify this. 16, 19. Now it is minus 19 gets cancelled. This is a 10 power 4 by 1.6 into 5. It is 8. So 10 power 4 by 8. This is 10 by 8. It is 1.25 into 10 power 3 ohms. That is 1.25 kilo ohms. 1.25 kilo ohms. Okay, that is the value of resistance, or dou V input by dou I input. See here, just they given this information. Instead of asking directly calculate the amount of resistance offered by the block, they are asking in terms of V input by I input. Okay, anyway, voltage by current is nothing but a resistance. Just I calculated the amount of resistance offered or produced by this block. Only that is the difference. Okay, next problem. Now an n-type semiconductor has conductivity 1 ohm to 1 milli ohm to ohm inverse to centimeter inverse. Conductivity of n-type semiconductor. Sigma n is 1 milli ohm to centimeter inverse. So milli means it is a 10 power 3 minus 3 ohm to centimeter inverse. Yeah, that is the sigma n value given. So it is n-type semiconductor first of all. By compensation doping, that means this is compensated. Now if you write the equation for this, sigma n is nd into q into mu n. Fine. After compensation doping, it is to be made a p-type semiconductor. Now after compensation, that means by adding some Na to that, and that Na should be greater than this Nd, then only it is compensated and it converted into a p-type semiconductor. P-type semiconductor with the same value of conductivity. Now sigma p also so is 1 milli ohm to centimeter inverse, that is a 10 power minus 3 ohm to centimeter inverse. But this is, we can write P into Q into mu P. P value is nothing but a, by adding some, they are doing compensation doping. Compensation means for n-type, to convert n-type to p-type you need to add Na. To convert p-type to n-type you need to add Nd. Now we are adding Na to this Nd. Now P is called net doping equals to, and its value is Na minus Nd. Why? Because it is after compensation doping, it behaves like a p-type semiconductor. Clearly they given it is a p-type semiconductor. Okay, that is the p value. Now I am substituting this one here. So sigma p equals to, p is nothing but a Na minus Nd into q into mu p. Okay. Okay, sir. Now simplify this. They given this one is 10 power minus 3, 10 power minus 3, and this is also they given it as 10 power minus 3. From this they given mobility. See this problem completely. What is the acceptor concentration that is needed for this? What is the Na value? You need to measure this. Give your answer in per centimeter cube. For this Ni of this semiconductor to be 10 power 9 per centimeter cube, and mu A and mu H is 950 and 300. So they are giving electron mobility is 950 centimeter square per volt to second, and hole mobility is 300 centimeter square per volt to second. Okay, now first I am using this expression. I am going to calculating parameters this end. Now, so ND is, we need to measure that ND into Q, 1.6 into 10 power minus 19 into mu n is, the given mu n is a 950 in equals to 10 power minus 3. Now ND is equals to 10 power 16 by 1.6 into 950. Okay, now I am going to simplifying this to get the ND value. So 95 into 1.6, 152. So its value is 10. So this 0 gets cancelled in this by 10 power 15 it is. Now I am taking it is 100 by 1.6 into 95 is 152 into 10 power 13. So 100 by 152. It is 0.65. So that is approximately 6.57 into 10 power 12 per centimeter cube. This is the value of ND. So far we get the ND. Now take that value and substitute here. Therefore, at this end, NA minus ND into Q, 1.6 into 10 power minus 19 into mu H, inside is 350, yeah, sorry, 300 equals to 10 power minus 3. Therefore NA minus ND equals to, so this 2 zeros, 10 power minus 17 minus 10 power 14, 10 power 14 by 1.6 into 3, 4.8. It is 10 by 4.8 into 10 power 13. So 10 by 4.8. So it is 2 approximately 2.08. Approximately 2 into 10 power 13. So now it is 2.08. 2.08 into 10 power 13, or 20.8 into 10 power 12 per centimeter cube. This is NA minus ND. NA minus ND, this is 20.8 into 10 power 12 per centimeter cube. Now taking this ND this side, now NA is 20.8 into 10 power 12 plus ND. Now just add the ND value to this. 20.8 into 10 power 12 plus 6.57 into 10 power 12. So it is 27.37. 7.37 into 10 power 12 per centimeter cube. This is the value of Na. By adding this much amount of impurity to that, the N-type semiconductor is converted into a P-type semiconductor, and at the same time it provides the same amount of conductivity what it is provided by the n-type semiconductor. This is a very nice problem. Okay, please be practice this. In this problem, so much information is available. Compensated doping we use. By using that, we converted n-type into a p-type. Okay, so equal conductivity is this, the another point. Okay, be practice this problem. This is very important problem. So you can expect this type of models. Okay, so next problem. Calculate the fractional change in conductivity. Fractional change in conductivity of an intrinsic semiconductor. Sir, fractional change. Change is the change in conductivity is delta sigma. Fractional change is this is change. Okay, fractional change means delta sigma by or dou sigma by sigma. That is the fractional change. Now, assuming that the change in conductivity is only due to the variation of intrinsic carrier concentration. Now they given one condition here. That condition is the change in conductivity should be only due to the variation of intrinsic carrier concentration with the temperature. Now first I am presenting the conductivity equation for intrinsic semiconductor. Intrinsic semiconductor. For intrinsic semiconductor, conductivity is Q into Ni into mu n plus mu p. Mu n plus mu p. This is the equation. So fractional change for intrinsic semiconductor. So I am adding I subscript to this. Yeah. Now it should vary with respect to Ni and temperature. Now I am going to representing Ni value. We know that Ni is square root of Nc into Nv, okay, into e power minus Eg by e power minus Eg by 2 kt minus Eg by 2 kt. Taking this value and substituting here. Now sigma I is Q into Ni value. So Ni value is square root of Nc into Nv into e power minus Eg by 2 kt into mu n plus mu p. And here, if you observe this, Q is a constant and this is also going to be a constant. Okay, at a constant temperature reading, and this is also going to be a constant. Now these three constants I am going to be representing by a parameter. Let us take A or some K I am going to using. I am going to representing that parameter by some constant K into e power minus Eg by 2 kt. That is the sigma I, where K equals to Q into square root of Nc into Nv into mu n plus mu p. That is the K value. Okay. Now I am going to differentiating this equation with respect to t on both sides. Now differentiating with respect to t. With respect to t. So now it is a d sigma I by dt equals to, okay, k into, just to differentiate this step in it, sir. I think so. Sir, one more here we forgot. That is, in NC and NV we have temperature T power 3. Here they mentioned with the temperature in our problem. So the temperature you need to add. That's why what I'm doing is our Ni value we've written like this. So this is Ni. Now this is already we've written some constant A naught into T power 3 by 2 into e power minus Eg by 2 kt. I'm going to use this because here temperature is has to be included because we are differentiating with respect to t, so you can't omit the t, so you need t here. That's why sigma I is, so now I'm writing sigma I is Ni is a naught into t power 3 by 2. Already we derived this equation, sir. Yeah. Now, so q into a naught into e mu n plus mu p, I am taking it as k. So now it is k into t power 3 by 2. That is okay. Now I am taking natural log on both sides first of all. After that I go for differentiation. So taking natural log on both sides. Now after that ln of sigma I is, because if I take directly natural log I get d sigma I by dt or d sigma by dt, okay, but I want d sigma by sigma. That's why I'm taking natural log equals to k is constant into ln of a plus b. So ln of ab is ln of a plus ln of b. Now it is ln of t power 3 by 2 plus ln of e power minus eg by 2 kt. Now ln of eg by 2 minus eg by 2 kt value is, both these two can be cancelled. Now it is, so ln of sigma I is k into, it is 3 by 2 into ln of t plus ln of these two gets cancelled. Now it is coming here. Now it became minus eg by 2 kt. Now I am differentiating with respect to t on both sides. Differentiating with respect to t on both sides. Now ln differentiation of this one is 1 by sigma I into d sigma I by dt equals to k constant into 3 by 2 constant. So differentiation of this with respect to t is 1 by t minus differentiation of this Eg by 2k is constant, and differentiation of 1 by t is minus 1 by t square. So it became plus, here you get 1 by t square. Now I am doing little bit modifications here. I am just rearranging this. I am taking dt this side. Whatever the dt here we have, I am taking the dt this side. Okay. Now d sigma by I by sigma I equals to k into 3 by 2 into dt by t plus Eg by 2kt into dt by t. So this is the fractional change in intrinsic semiconductor conductivity. K into 3 by 2 into dt by t plus Eg by 2kt into dt by t. Now I am taking dt by t common in this. So finally the value is t sigma I by sigma I equals to some constant k into dt by t into 3 by 2 plus Eg by 2kt. So one thing here already we are using k, that's why I am taking this is some k1 proportionality constant. So some k1 I am representing that one by some name k1, where k1 is this much. Okay, so this is the equation. Here simply whatever the basic expression we have, we taken that basic expression. Okay, so this is a ln of k1. Now ln of k1 is it is constant, it is 0. Small confusion, sir. Taking both sides natural log. Once taking natural log both sides, ln of abc is ln of a plus ln of b plus ln of c. This is 0. Sorry. Yeah. This is your final equation, sir. Now d sigma I by sigma I equals to dt by t into 3 by 2 plus Eg by 2kt, or you can take it instead of sigma, you can take it as the sigma also. Okay, now based on this we go on do one problem. So at particular temperature at 300 Kelvin they give some temperature, then some conductivity at a temperature of other than this, for example 350 Kelvin, what is the conductivity of a material? At that time you can use this expression. Now we go on check that. See this, the conductivity of an intrinsic silicon sample at 300 Kelvin is 4.4 into 10 power minus 4. So at a temperature is of 300 Kelvin, conductivity is 4.4 into 10 power minus 4 ohm to centimeter inverse. Ohm to centimeter inverse. Now determine the conductivity of a semiconductor if temperature rises to 315 Kelvin. what is the conductivity. That is the problem. In this case, there is a change in temperature. Now the delta T is, or dt is 300, 315. Now it is 15 Kelvin is the temperature change. Okay. Now our standard equation so far what we derived is, from previous problem you can write d sigma I by sigma I equals to delta T by T, or dt by T, into 3 by 2 plus Eg by 2 kT. In this problem, so this is T1, T2. Delta T is T2 minus T1. It is T2 minus T1. That is 15. Fine. Okay. Sigma I. That is the sigma 1 value. Now what is sigma 2? Now, so sigma I in this problem is at 300 Kelvin. It is 4.4. Okay. Now see this. dt is 15. You need to get d sigma, and 3 by 2 plus Eg. So we know that for a silicon sample at room temperature, because I am taking here T is 300 Kelvin. 300 Kelvin standard, because at this point I know the energy gap. So it is 1.1 electron volt. We know that. Okay. And I know the KT value also at this temperature, at this point. And KT value is 25 milli electron volts. 25 milli electron volts. Now I am using this data and substituting that data in this equation. D sigma by, so it is a D sigma I by sigma I equals to dt. It is 15 by T is 300 into 3 by 2 plus energy gap 1.1 by 2 into 25 milli. 25 milli means 0.025. So now it is 15, it is 20 times 1 by 20 into 3 by 2 is 1.5 plus it is 1.1 by 0. That is 1.1 divided by 0.05. That is 22. So now it is 23.5 by 20. So 23.5 divided by 20. That is 1.175. This is the value of d sigma by sigma, or d sigma I by sigma I is this much, 1.175. Okay, we need how much? So what is our problem? At T equals to 315, what is the sigma value? Conductivity. So the required data is, so conductivity change you are getting. So from this, d sigma I is, by changing temperature, 1.175 times of sigma I. We need sigma I2 or sigma 2, that is sigma I1 initial value plus d sigma I. So sigma I is, they given it as 4.4 into 10 power minus 4. So 4.4 into 4.4 into 10 power minus 4 plus, okay, I do one thing. This is sigma I. I'm keeping as usual sigma I plus d sigma I is 1.175 sigma I. Okay, now this is a 2.175 sigma I. So it is now 2.175 into 4.4 into 10 power minus 4. That is the new conductivity. New conductivity. Okay, so units are ohm to centimeter inverse. Just we done this problem based on the previous expression what we derived. Okay, based on previous only we derived this problem. Okay, sir, is it okay? Now I am going to next problem. Yeah, energy band diagram bending. Okay, we discuss this one in the next session. We have diffusion. There we discuss about this. There is much information, you have to extract much information from that problem. Now, okay, show that the conductivity of silicon sample is minimum when it is slightly p-type. Already we done this. See, the conductivity of intrinsic semiconductor is writing this as a q into ni into mu n plus mu p. Sorry, silicon. Now they did not mention it as intrinsic. Okay, so conductivity is n into q into n into mu n plus p into mu p. Okay, so for minimum or maximum values, differentiation of this with respect to that variable equals to 0. Now you get the value of the variable at which conductivity is minimum. Okay, but here two variables, n and p are the two variables. So I am going to converting that one into a single variable, n into p equals to ni square. Ni square. Now from this p equals to ni square by n. So sigma I, now sigma, not I, sigma is q into n into mu n plus p value ni square by n into mu p. Now in this, if you observe, it is constant, mu n constant, ni constant, mu p constant. Only n is the variable. So only one variable. But in this case, two variables we have. Now I am differentiating this with respect to n. Therefore, d sigma by dn is q constant as usual. The differentiation of this with respect to n is 1 into mu n plus ni square into mu p is constant into differentiation of 1 by n with respect to n is minus 1 by n square. So for minimum or maximum value, it should be 0. The value of this one should be 0. By equating this one to 0, you get q never equals to 0. Now remaining part, this is 0. So mu n minus ni square into mu p by n square equal to 0. From this, at a value of n equals to ni into square root of mu p by mu n, conductivity is minimum. And one more thing, here we know that mu n is greater than mu p. We know this. We know this. So once mu n greater than mu p, n is less than ni. Now amount of electron concentration is less than intrinsic carrier concentration. In a semiconductor, majority carrier concentration is more than intrinsic carrier concentration and minority carrier concentration is less than intrinsic carrier concentration. So it is less than, n is electron concentration less than intrinsic carrier concentration. That means electrons are minority charge carriers. Okay, in p-type semiconductor, electrons are minority charge carriers. And we get p value also at the same time. Now we can get the p value. So we know p value, just before we written, p is ni square by n. just substitute here. It is ni square by n value is ni into square root of mu p by mu n. By simplification, we get it as ni into square root of mu n by mu p. So we know that mu n is mu n is greater than mu p, not much. So from this, p is ni into square root of mu n by mu p. So we know this one. So mu n is greater than mu p. Therefore, p is greater than ni. P is greater than ni. So P greater than Ni means the semiconductor behaves like P-type semiconductor. Okay, this is not much greater. That too it has a square root. Okay, that's why slightly P-type semiconductor, not extreme P-type semiconductor. Slightly P-type semiconductor. That means just it is converted from intrinsic to P-type. That's it. Just a little bit doping they added. Okay, so that is the problem here. Okay. Now, okay, thank you. Thanks for spending your valuable time with me. And don't forget to use my code during subscription. My code is VRAW10. Use my code during subscription to get 10% discount. Okay, and subscribe the bell symbol there to get the notifications about my classes. Okay, and here please give me your comments to strengthen myself and to give a better information, much information too, for further coming students. Okay, and please join the Telegram group and get the updates of classes. And thank you, once again I am thanking to one and all for your spending your valuable time with me. Thank you very much. So once again I am welcoming you all to India's largest online platform, Unacademy. Okay, thank you very much.